So we just stopped the Heart of Algebra, page 5, and we're going to pick this up about middle of page 5 here. So we're going to start with the definition, and this is of the domain. So it says the domain of a function is the set of all inputs for the function. So we actually have already seen this definition before. I just wanted to remind you there will be some domain, probably some range problems on the SAT. So make sure you have that memorized. The domain is a set of all inputs. The range is a set of all outputs. So far with the domain, so let me go back to our, I think it was page 2. Okay, we have looked at just a relation here. Okay, so it says what is the domain and range? So we actually just wrote out what each input was and wrote out what each output was. Okay, now we're going to be given something that looks like this. Okay, so we're going to be looking at what the domain and range of something like this would be. So let's look at the domain. So it says to find the domain of a set of ordered pairs, we will just write out each input value, okay, which is exactly what we did. It says, but what if the function is given to us as an equation? Okay, so it says, for example, what is the domain of f of x equals 3 over x minus 1? We need to find what the x values will be, okay? That means we need to find the input, okay, which is exactly what the domain is. Okay, so to find the domain when we're given something like this, we're going to be looking for two things, fractions and even roots, okay? I don't care about the odd roots. Okay, so this is square root, fourth root, sixth root, okay? The cube root, which is third root, fifth root, this does not apply. Okay, so for fractions, the denominator cannot be 0. You cannot have 0 in the denominator. That's the rule. For even roots, there cannot be a negative number underneath an even root. Okay, so if we have a fraction, we're going to just put the denominator can't be 0. Okay, everything else can be an input. For even roots, we're going to say whatever is underneath the root can't be less than 0. Okay, it can't be negative. Everything else is fine. Okay, so let's look at this very first example. Number 1, f of x equals 1 over x plus 3. So we want to know what the x's can be, okay, or what our input values can be. Okay, notice that we have a fraction. Okay, because we have a fraction, the denominator can't be 0. So I'm just going to write that. The denominator, which is x plus 3, can't be 0. Okay, that means I'm just getting x on one side. X can't be negative 3. Alright, so that means x can be anything as long as it's not negative 3. Okay, so I'm just going to write domain is the set, remember domains are sets, of all x. Okay, x can be anything such as x can't be negative 3, such that x can't be negative 3. Okay, so this reads the domain is x such that x can't be negative 3. Okay, it can be anything as long as it's not negative 3. Okay, which you can check. Plug anything in here, you're going to get an output value. Okay, more examples on page 6. G of x equals square root of 2x minus 6. Okay, again, we have an even root here, which is a problem. Okay, underneath even roots, odd roots, you can have a negative number. Okay, underneath even roots, you cannot have negative numbers. Okay, so underneath an even root, it needs to be greater than or equal to 0. Okay, this could be 0. The square root of 0 is 0. So you can put greater than or equals to 0. Okay, let's get x to one side. So that would be 2x greater than or equal to 6. Keep solving for x. X is greater than or equal to 6 halves, which is 3. Okay, so there's our rule for our domain. So the domain is a set of all x's such that x is greater than or equal to 3. Okay, so when you go to pick inputs, okay, I would probably start at 3. You could have 3, 4, 5, 6, 7, 8, 9. You wouldn't use 2. You wouldn't use 1. You wouldn't use 0. Okay, because if you plug any of those numbers in here, it's going to give you negative, which you can't do. Just a little side note, if you have the cube root of a negative number, so for example, the cube root of negative 8, okay, that is actually negative 2. Okay, so you can have negatives underneath cube roots, fifth roots, seventh roots. Okay, so odd roots you can have negatives, so this does not apply. Number 3, h of x equals 4x. We want to know the domain here. Notice we don't have a fraction. We also don't have an even root. So we don't have a rule for this. Okay, so I'm just going to put all real numbers, which I put in here real, the word real, just because we're not going to be using imaginary numbers right now. Okay, so there's no rule for this one. It can be any number. You can choose anything. Number 4, s of t equals t plus 2 over t times t minus 2. Okay, here we have a fraction. Okay, with fractions, the denominator can't be 0, so I'm just going to write the denominator can't be 0. Okay, we can break this up. If t were 0, you would have 0 times something, doesn't matter what this is. Okay, it's going to be 0, so that would be t can't be 0. If t minus 2 were 0, the whole thing would be 0, so I'm going to write t minus 2 can't be 0. So we can break that up using the zero product rule. This is as simple as that will go. We can get t again by itself, so t can't be 2. Okay, so our domain would be all t such that t isn't 0 and t isn't 2. Okay, so if you were going to choose your inputs, you could choose 1, you could choose 3, you could choose 0.5. You just wouldn't choose 0 and 2. Okay, number 5, we have w of x equals 1 over the square root of x plus 2. Okay, we have a fraction. Okay, we also have an even root. That's a square root. So let's go ahead and start with the even root rule. So whatever is underneath the root has to be greater than or equal to 0. Okay, but if this were 0, so we had a 0 square root of 0, okay, that means that we would have 0 in the denominator. Okay, so let's just erase the equal to part. Okay, so that means the denominator, or underneath the root, x plus 2, just needs to be greater than 0, not greater than or equal to. The only reason I deleted the equals to was because of our rule for denominators. Okay, get x by itself, x needs to be greater than negative 2. Okay, so the domain is all x such that x is greater than negative 2. Okay, so I'd probably start, greater than negative 2. Okay, so I'd probably start at negative 1. It's greater than negative 2. And a 0 would work. Okay, so that is some examples for domains, which you will see on the math part of the SAT. Bottom of page 6, we're going to go into graphing functions. We're going to start by just using the XY chart first. That's probably the way you guys have seen this. So it says when the rule of a function is given by an equation, then to graph the function, we make a table of values, plot those points, and then connect each point. Okay, so first we're going to graph the function f of x equals 4, a constant function. Okay, so f of x equals 4. First, before you ever graph, you need to find your domain. Okay, so this one doesn't have a fraction, doesn't have an even root, so the domain would be all real numbers, meaning you can choose anything for your input, you're going to have an output. When I can choose anything, most of the time for my inputs, I do some negatives, I always do 0, and I do some positives. So negative 2, negative 1, 0, 1, 2 would work. Okay, so I just chose some inputs because I could choose anything. Okay, and then f of x is going to be our outputs. Okay, so just reading this, it says to graph the function, we make a table of values. So we've started that. Then we're going to plot the points and then connect the points. Okay, so when you input a negative 2, the output says it's 4. When you input a negative 1, the output says it's 4. When you input a 0, output 4. Okay, these are all going to be 4s here. It's a fairly simple one to graph. Okay, so x's, we need to at least go out 2 each way. Y's, we at least need to go to 4. So we have negative 2, 4. I'm plotting these points now. Remember, input, output looks like negative 2, 4. This is negative 1, 4. Okay, so negative 1, 4, 0, 4, 1, 4, and 2, 4. Okay, so we've plotted the points. Now we're just going to connect. Okay, so there is our first function that we've graphed by hand. This is probably a review for you guys. Okay, on to page 7. Graph the function f of x equals x. Again, find the domain first. You always need to find the domain. Since we don't have fractions, we don't have an even root, it's going to, again, be all real numbers. So I'm going to just choose the same numbers, -2, -1, 0, 1, and 2, which I should have put an x here. And our output is f of x. Okay, so our function says to take the input and you output the input. Okay, so when you input -2, the output's -2. When you input -1, the output's -1, 0, 1, and 2. Okay, so we want to graph these points. So again, make sure you go out 2 each way, and then it looks like the y values need to be about the same, or the same. Okay, so our first point is -2, -2, -1, -1. We have 0, 0, 1, 1, and 2, 2. And then connect the points. So we have graphed our second function. Next function, graph f of x equals x squared. Okay, again, make sure you write your domain. We don't have a fraction, we don't have an even root. We have a square, not a root. There's a difference there. Exactly opposite of each other. So it's still all real numbers. I'm going to use the same numbers again. You can change these up. Okay, so -2, -1, 0, 1, 2. Okay. This time our function says take our input and square it. Okay, so when we input -2, we're going to square that. That is -2 times -2, which is +4. -1, same thing. Do -1 squared, which is 1. This is blurry. Let me try to clear this up. There we go. 0 squared is 0, 1 squared, 1 times 1 is 1, 2 squared, 2 times 2 is 4. Okay, now to graph that, again, our window is the same for the x-axis. For the y, it looks like we need to go to at least 4. 1, 2, 3, 4. Okay, so -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. Okay, so far all we've graphed are straight lines. Okay, this one is actually a curve, which you can kind of see. You can't get a straight line through these. And it also has a turn in it. Okay, because we're turning, we just don't go straight. So this is what x squared looks like. Okay, which we're going to look at these in more detail. It doesn't come up in the heart of algebra. I think it is in the next section we'll do. Eventually, we're not going to graph anything by hand. It's just, or not by hand. We're not going to graph anything using an XY chart. Okay, but this is very basic. Next graph is x cubed, x to the third. Again, no fraction, no even root. So we're going to use all real numbers. I'm going to use a couple more just because this one is a little more complicated than the one we just did. I'm going to use, let's just go to -3, -2, -1, 0, 1, 2 will be fine. Okay, so -3 is the input, so we're going to cube that. So -3 cubed, that's -3 times -3 times -3. Okay, which is negative, right? Okay, so the answer is negative because we have 3 negative signs. -3 times -3 is +9 times -3 would be -27. -2 cubed is -8, which I'll write that out. So that's -2 times -2 times -2, so -8. -1 cubed is -1 times -1 times -1, which is -1. This would be 0, this is 1, this is 8. Okay, so when we graph this, we need to at least go out to -3 here, 2 here. Up to 8 looks like our highest point. I'm going to go up by 2's here. 2, which I need to write. 2, 4, 6, 8, -2, -4, 6, 8, 10. I'm going to 27, which I'm not going to write in all of those. Okay, so we're -3. We're way down here, which I'm not going to write in. -2, -8. So 2, 4, 6, 8. -1, -1. So -1 middle here. 0, 0. We have 1, 1. And then 2, 8. Okay, so this looks a little strange. It actually is a curve like this. Remember, this point is way down, so by the time it gets to -3, it should be way down here. Okay, so here we have x cubed. Again, we're going to look at this more in the next section, because eventually you're going to be able to see this, and you'll know it looks like this. Okay, so we'll stop graphing with XY charts. I think we have 2 more we're going to do with XY charts. Next one is absolute value of x. Okay, what the absolute value does is it just takes the positive version of the number. So for example, the absolute value of -3 is 3. The absolute value of +5 is 5. So it just takes the positive version of the number. Again, the domain is all real numbers. You can take absolute value of anything. Okay, so x, I'm going to choose -2, -1, 0, 1, 2, and f of x will evaluate here. So this is the absolute value of -2, which would be 2. Absolute value of -1 is 1. Here we have 0, 1, and 2. Okay, so when graphing this, we need to go out -2, +2, and the y's looks like we just need to go to 2. So -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. Okay, this kind of looks like the parabola, but you can see it is actually in straight line. So absolute value of x looks like a V. One more we're going to do with an XY chart. So this is top of page 8. It says graph the function f of x equals the square root of x. Okay, so we need to find the domain first, okay, which you can see we have an even root. Okay, so remember, underneath an even root, it needs to be greater than or equal to 0. It cannot be negative. Okay, so that's our domain. Our domain is all x's such that x is greater than or equal to 0. This is why we write the domain. Okay, if you were to do just starting here, -2, -1, 0, 1, 2, okay, you wouldn't be able to evaluate some of those points. Okay, so since our domain, sorry that's blurry, I'm trying to clear it up. Since our domain is x such that x is greater than or equal to 0, let's just start at 0. So let's do 0, 1, 2. I also want to do 4 here. Okay, so this function says take your input, take the square root. Square root of 0 is 0. Square root of 1 is 1. Square root of 2. You probably don't have that memorized, so I'll do that with you. Square root is behind the x squared. You can see you've got the root there. So second, press that button. 2. Press enter. About 1.41. Square root of 4 is 2. Okay, so x's we need to go out to 4, 1, 2, 3, 4. Y's we just need to go up to 2. Okay, so we have 0, 0, 1, 1, 2, 1.41, and 4, 2. Okay, so the absolute value of x looks like this. So that is what absolute value of x looks like. Now, you've probably learned that when you're solving equations for x, and you have something like x equals square root of 4, okay, that gives you 2 solutions. X equals 2, x equals -2, okay, which is correct. Here we didn't put that, so we have absolute value of 4. We didn't put -2 here. Okay, if we did, then it wouldn't be a function, because that means 4 goes to 2, 4 goes to -2. Okay, so you choose when you're graphing the absolute value of x or the 4th root of x or the 6th root of x. We almost always choose the positive values. Okay, so here you could have 1.41. Okay, again, that's not a function if you choose that too. Okay, so we only choose the positive version. Okay, again, we have some extra steps to graph on a calculator. Okay, so if you don't have a graphing calculator, go ahead and fast forward through this part. If you do, let's go ahead and look at evaluating. And then it looks like the bottom of page 8 and top of page 9 is just going to be graphing with a calculator. Okay, so to graph with a calculator, the first step is to, let me clear this out, go to y equals. Okay, so y equals, that's going to just be your function. Okay, so we do y equals. Okay, here you input your input function. Okay. Then we're going to change window. I'm just going to go ahead and write out the steps, and then we're going to graph. And I'm going to put in parentheses, turn your stat plot back off, okay, because if not, you're just going to have these weird points. Turn stat plot off. Okay. So let's go ahead and graph. It says graph the function f of x equals x cubed plus 36x minus 4 on your graphing calculator. Okay, so I went ahead and pressed y equals. We're going to input that function, which let me get that glitter out. We are graphing x cubed. Okay, so anytime you see a variable when you graph this function, you're going to use this button here. So you have x, t, theta, and n. We're just using the x. So that's our variable. Okay, then we're going to use the caret button to cube it. Make sure you arrow down. If you have an older version, you don't need to arrow down. Okay, but the newer version, arrow down, is going to keep it up in the exponent if you don't. Okay, plus we have 36x and then minus 4. Okay, so there's our function. Our window, it says to change our window. We don't really know what the window is right now. I'm going to go ahead and change this to standard window, which is -10 to 10, -10 to 10. Let me just explain this really fast. We've looked at the stat plot, -10 to 10, x min, x maximum. This is x scale. I normally never mess with that, so just leave it at 1. Y minimum, y maximum, and the y scale at 1. Okay, this is standard window, -10 to 10, -10 to 10 for both of those. Before we press graph, let's go ahead and turn our stat plot off. So remember, you go to second y equals. Okay, go into enter here and turn your stat plot off. Okay, if you don't turn it off, you're going to have these random points in your graph. It's going to look a little bit off. Sometimes it also won't graph it, okay, if it's not included in your window. So make sure you turn that off. Okay, let's go ahead and graph it and see what we get. Okay, as you can see, this is a terrible picture of this graph. Okay, you can barely see it. So we need to change the window. It looks like we need to go taller. Okay, so let's try to change. Yeah, it looks like we need to go a little bit taller. To figure out how to do your window. Okay, and before I go into that, how your calculator graphs is exactly how we graphed this. Okay, it chooses random numbers for the x values. Okay, then it evaluates them at those x values, and then it connects the points. Okay, and you can see this if you go to second graph or go to table. Okay, you can see this is what your calculator graphed. It graphed a -4, and this was your output. It graphed a -3, this was your output. Okay, so it graphed all of these points, and then it connected. It graphs exactly how we graph, except this is a lot faster. Okay, so if we were to graph this by hand, it would take us a while. Okay, again, the domain would be all real numbers, but it's going to take us a while because these are, x cubed is large numbers, 36 is a weird number. Okay, so this is exactly how your calculator does it. It's just more accurate and a lot faster. Okay, this is also a good way to show you your window, what your window needs to be. Okay, so we'll go back to table. Okay, so when x is -4, the y is -212. Okay, so it's increasing or decreasing very fast. When x is -10, the y is -1364. okay, going positive direction. Okay, so that was the end of our x window. But going in the positive direction, which you can't see that because of the glare, when x is 7, the y is 591. Okay, when x is 8, the y is 796. Okay, so we need to change our y values here. So going back to the window, I think a good y minimum would be negative, let's do 500. Y maximum 500, we'll just keep it the same. We'll see if that gives us a better picture, which I can already tell it does. So there's a good picture. Okay, so now when we copy this, make sure you write down the window. Okay, so we did negative 10 to 10 here, and then we did negative 500 to 500, and we get this picture here. Okay, so make sure you write down the window when you graph. Okay, always write down your window. Okay, page 9, we're going to do one more. It says graph the functions f of x equals x squared minus 3 and g of x equals x cubed minus x minus 3. Okay, so we're going to be graphing two functions in our calculator. And then it says find the points where the graphs intersect in this viewing rectangle. Alright, so let's go ahead and go to y equals. Let's go ahead and input these. So we have x squared minus 3. The second function we just need to arrow down. It brings us to y2. This is going to be our second function. X cubed minus x minus 3. Mine has colors here. So if you bought the plus C, so if you have a C here, that means you're going to have it in color. Okay, so the first graph will be blue, the second will be red. If you have an older version or if you didn't buy the C, it's going to be all black, which is fine. It's not a big deal. Let's go ahead and look at what the tables for this, actually, we'll probably, yeah, there we go. Okay, so look, you have the same inputs here. Okay, here's your first graph, here's your second graph. Okay, it looks like these numbers are fairly simple. They're not increasing too much, so I'm just looking at negative 4. Y1 is 13, Y2 is negative 63. So we may go out a little bit more on the window. Negative 10 to 10 for the X looks good. Y minimum, let's go to like negative 60 would be fine. And let's just go to 60 here. Okay, and we'll graph that. Okay, so there's our first function, that's x squared minus 3. And our second function is there. Okay, so it says find the points where the graphs intersect in this viewing rectangle. Okay, which I don't know why it says in this viewing rectangle. Okay, so we need to find where these points intersect. So if you look here, you can see there's some weird thing going on here. So let's go ahead and zoom in. Let's see what's happening at this point here. So if you go to zoom, okay, you can zoom in. You want to zoom in around this area. So I'm just going to try to come to the middle part here and press enter. Okay, so I zoomed in where that cursor was. Okay, so it looks like you've got an intersection 3 places. So it looks like it came here, intersected here, went down again, intersected, and intersected again. Let's again zoom. Okay, so zoom in where this cursor is. Let's try one more time. This might be too close. We'll see. Okay, so you can see this intersection here. And then there's another. So you have an intersection here, an intersection here. Alright, I'm going to zoom back out. Okay, so I like the picture we just had before. Okay, so you could kind of guess and see where the intersection points are, but the calculator will actually calculate exactly where the intersection points are. First, let's go ahead and draw this picture. The window they gave us when we zoomed in was that, so I'm going to go ahead and draw it with that window, which your window is probably going to be different. Okay, so this is just the window my calculator gave me. So my calculator is negative 2.52, x minimum, negative 2.52 approximately, to 2.48 approximately. And then the y minimum is negative 17 0.93, you can see that, and the y maximum is 12.07 approximately. Okay, and I just want to draw that picture approximately, which looks like this. And this, okay, so it intersects here, comes back down, and about here. Okay, so we have 3 places here. Okay, so we want to find those intersection points. The calculator can do this for us. So if you go to second, trace, you see calculate is behind that. And we want to go down to intersect. Enter. Okay, it's asking for the first curve, which you can see if you press the left and right, it's actually on the red curve here. Okay, so you can get around your curves using the left and right button. So it's on the first curve, so look down here where it's asking for the first curve. Go ahead and press enter. Now second curve, it's actually jumped to the next curve. You can see that the cursor now is moving on the second curve, which is what we want. And then we're telling the calculator to guess what that point is. Okay, so it looks like this first point is about negative 0.62, negative 2.62 approximately. Your calculator might give you something else. It's guessing here, which is better than our guess. Okay, we have another one. So second, calculate, intersect. Okay, again on the first curve, but now I'm going to go around this point. Okay, so first curve, second curve, it already jumped there and guess. Now it brings us to that second point, which it looks like is basically 0. Okay, this number here is 3.363e, which that means 10 to the negative 14th. Okay, so that means you would write 3.363 times 10 to the negative 14th, which your number again in your calculator is, will probably be different. It might even bring up 0. So this tells us to take this number, take it to the left 14 times. Okay, so I didn't count that, but these would all be zeros here. 14. Okay, so that's basically 0. And negative 3, which our picture does not look like that. Okay, so there's our third intersection point, second intersection point, and we want to find the third one. So intersect. Okay, again, we're going to hover over that third intersection point. So I'm still on my first curve, and then second curve, and then guess. It looks like 1.62, this is what my calculator gave, 1.62, negative 0.38. Okay, again, your calculator might give you different points. Okay, bottom of page 9, we have the vertical line test. Okay, so it says a graph is the graph of a function if and only if no vertical line intersects the graph more than.
We can tell if a function or a relation is a function if we're given the points. Okay, so we just look at our inputs and make sure that they have just one output. Okay, so now if we were given a picture of the relation, we can tell if it's a function or not. Okay, so for example, if we were given, here's our x-axis, here's our y-axis, we were given a picture like this, okay, and we're saying, is this a function or not? Okay, so we don't know what these points are. We're not even given a window, okay, but we can tell you if this is a function or not. So it says a graph is the graph of a function if and only if no vertical line intersects the graph more than once. So that means you take all possible vertical lines, okay, and so I'm just doing a couple here. As long as it just hits the graph once, it is a function. Okay, so there is no vertical line that you could take on this that would hit the graph twice. Okay, so this would be, yes, a function. Let's do this picture. So here's our x-axis, here's our y-axis. Let's say we're given this picture here. Okay, take vertical lines, actually every vertical line except for one here, it's going to hit it twice, so this would not be a function. Let's do a couple more. What about something like this? So it looks kind of like our first graph. Okay, take vertical lines, that's fine. Take a vertical line, that's fine. Take a vertical line, there, that is not okay.
So we have one vertical line out of those three that we drew that hits it more than once. So this would be no. Let's do one more. So let's say we have a picture like this. This is the x-axis. This is y. Okay. Take vertical lines. Okay, hits it just once. Take a vertical line, hits it just once. Take a vertical line, it hits it just once. So this one would be yes. Okay, so that is a very simple test that works every time with testing for functions. Why does this work? Let's just quickly look at that. For this function, you have our input here. The output would be here. Okay, so for this input, you don't have any other output. Okay, for this input, you have just one output. Okay, for this input, you have just one output. Okay, looking at this function, for this input, you have two outputs. Okay, so if you were to do an XY table, okay, maybe this is 2, and you have two outputs here. So maybe this is 2 and -2. Okay, but for this one, for every input, you would have just one output. Okay, so this is not a function, this would be a function. So that's why that works. Okay, so we're going to go ahead and stop here. So that ends part 2 of the Heart of Algebra. When we come back, we're going to review everything we've done so far, and then go into piecewise defined functions.